All right, we've been talking about arrays. In Python, we call them lists just because they're slightly different. I believe I've mentioned this, but I want to go ahead and mention the difference between an array and a list in technical terms. An array is fixed in length. You tell the language, I want an array of integers that is 15 items long, 15 elements long. That's what you get. It's not going to be any longer. It's not going to be any shorter. If you want it to be longer, tough, you would have to reallocate. You'd have to ask for a new array and then copy all the elements into it. You wanted to delete 5 elements from the 10 of it? Too bad. You'd have to allocate an array that was 5 elements shorter and then copy all the ones that you wanted to keep into it. So this is the big difference. We could simulate that in Python by allocating a list like this. Now when I say allocate, I just mean create. We're telling Python that we want an array. So we could say, I want an array of numbers that is 15 elements long. Or we could say, I want an array of strings, right? That is 15 elements long. That's what the other languages do when you try to use an array. So these are Python lists that we could treat as arrays. They are empty arrays, not meaning they don't have any elements, but that there's no data inside the elements. It's all zeros all the way across. So it's all empty strings all the way across. The book goes on and on about arrays and does not really talk about lists. Lists are a more modern programming structure than arrays are. So until like the 70s or 80s, early 80s or whatever, you just dealt with arrays. That's what you had, from 1940 to 1980. That's all you had. So it's classic stuff. You have to know them. It's just that the guy who invented Python invented it 30 years after, all the other languages that were invented. So he made it work a little bit differently. Okay. But if you're going to use lists, which is the Python way, you just declare a list like that. That's an empty list. So this is a Python list masquerading as an array. And so is this, right? This is an empty list, and if you want data into it, you have to call .append. Array.append, put your favorite number in, 100. Array.append, put another number in it, 200. Array.append, put your other favorite number in it, and then when you print the array, it'll look something like this in Python. Something like that, right? If you call append a couple of more times, it'll add values to it. You could delete one of those items if you wanted to. You could say delete array item number 2. No, 1. Which one is array element number 1? It's the 200, right? Because we start counting at 0. Index 0-based indexing. So that's 0, that's 100, that's 2. And now when we print the array, we get 100, 300. That's the kind of stuff that you can't really do with a strict array in the languages like C and C++ and Java and things like that. Ones that follow the strict textbook computer science definition of an array. Is it more flexible and awesome to be able to do this kind of stuff rather than just be stuck with an empty list? Yeah, it is. Are there any disadvantages to Python not having arrays per se? I don't know. Accessing lists is a little bit slower than accessing arrays because arrays are guaranteed to all be in sequence in computer memory. So if you load up an array of 1,000 items, the computer just issues one read to the disk. It's all there. But lists could be stored in any order, and it's up to the language to bring them in order. So it might have to hop around in memory. So yeah, arrays are a little bit faster, but Python isn't the fastest language on the planet anyways. You're not going to write video games in Python or anything. I mean, video games that you would sell. There is a cool module called Pygame, I believe, Pygame. It's really fun to look at. You could download Pygame, and then you could download code that makes games, like a little shooter, you know, that where you have a spaceship that moves left and right, and you shoot aliens that are up there, or maybe a, you know, a guy who's running along jumping, like, you know, Mario or the old, you know, Pitfall or Jumpman games if you're 40, 50 years old. So, not that Mario's old, but Pitfall is. Okay, so anyways, I recommend looking at Pygame just for the total fun of it. All right, so array.append, and then delete. And when I say array, this is the variable name. If you called your array colors, it'd be colors.append. Delete colors subscript 1. If the array was called ages, ages.append, ages subscript 1. Right, that's just the variable name. I had another thought. I'm fumbling for it. Poof, gone like the wind. Okay. So, searching an array for an exact match. Sometimes you need to search through an entire array to find a value. Well, why would you need to search through the entire array? What if you don't find it? What if I'm looking for somebody exactly with the age 27? A linear search is when you just start at the beginning and you go to the end. So I say, are you 27? You go, no. I go, are you 27? No. I go, are you 27? You go, yep. So, woohoo, I found my person. I could stop there, right? So I don't have to go through the entire array, but I might have to. I might have to keep going all the way in, and then y'all tell me, nope, none of us are 27, so, you know, too bad. I had to go all the way to the very end. Is a linear search the most efficient way of doing it? No, but it's what you have to do if your data isn't sorted, right? I didn't make y'all come in for pre-assigned seating arranged by age. That'd be ridiculous. But if I did, I could do it this way. I go to the middle person. I say, are you 27? You go, no, I'm older. And I go, okay, I need to go this way. I say, are you 27? You know, just like our guessing game where we guess 50 and then we guess 25 and then we guess 37. That's called a binary search. But you can only do that if the data is sorted. Keeping data sorted in memory is a more expensive task, relatively. Why? Because when you put it into the list, you have to rearrange things. You have to shuffle things, right? And if it's an array, it's even worse because you can't delete items and insert items into the middle of an array, right? For the reasons I told you about. You know, the array doesn't shrink. So anyways, keeping data sorted is kind of a problem. You could fix that by creating an index. And that's what databases do. They have an index that you can use that keeps the data sorted. So if you said, you know, I want, you know, 1,000 records where, you know, everybody who lives in Oklahoma City who has bought a car recently, you know, and then it goes and it brings you all of them. And maybe you say, okay, but I want it sorted by last name, comma, first name. It checks its indexes and it builds that and it brings it back so that you can process it. You know, that kind of database stuff. And if you're going to take a database course, then you're going to know all about that stuff pretty soon. So an index is one way to get around the fact that if the data is not sorted, you'd have to do a linear search. But if you don't want to do a linear search, you have to keep the data sorted or you have to have an index. And we're not going to talk about how to create an index. Just tuck that away in your brain from when you take a database course. So there are examples. I am recording and we have volume, do we not? Testing, testing. Yeah. All right. So you have 3-digit item numbers, but they're not non-consecutive, right? Sometimes you have what's known as a key, a record key. And a key should be a value that is not meaningful, actually, right? You can't base somebody's key based on their first and last name. What if they change their name? People do it all the time. You know, Social Security numbers are supposed to be more valid, but what if somebody comes in and they don't have a Social Security number? You know, I doubt Canada has the same system that we do, you know, Saudi Arabia, whatever. You know, they probably don't have Social Securities like we do, and if they do, you could still have duplicates, right? If they happen to be at the same link. You couldn't guarantee that they were unique. So your system will probably be generating, and I'm talking too much about databases, your system will probably generate keys each time a new record is generated that is not meaningful. What do I mean by not meaningful? It's not based on the data. It's not based on your name. It's not based on your birthday, your Social Security, whatever. It's just an item number. Those item numbers could be randomly generated. It randomly generates one, and then it checks to see if that one was already in the list, right? And so maybe not, but anyways, if we have an array full of products and Amazon stuff they're ordering from us, our memory may not have them all in order. So if they order item 731, I'm going to have to go straight through the array, looking through the end, looking until I find out whether it's there or not. Customer orders an item. We need to check to see if the item number is valid, right? Create an array that holds the item numbers, and then we can search the array for an exact match. Now, item numbers are boring if I just make a list of numbers, but we could do that. We could do that in Python. Here's the pseudocode for it. Create an array. They call it populating. Populate it with data. Now it's time for an item search. Ask for the element value to search. Ask for the value to search for. I'm going to call that the target. So, just something like target is equal to input, right? So the better term for that would be input target. Then we need to do a loop. We could do a while loop, we could do a for loop, we could do whatever we want. So, I'm going to declare a variable called found and set it equal to false. If I wanted to do strict pseudocode, I'd probably do a set. Or if I follow different rules for Python, for pseudocode, I would do something like that, Anyways, we know what that means, but we know that set is not a Python word. We may remember that we have to use uppercase F's and T's for trues and false in Python, so I'm just going to do that. All right, then I would start going from the beginning of the array to the end of the array. I could do it with a while loop, I could do it with a for loop, I could do whatever. I'm going to do it with a while loop first, and then we're going to rewrite it using a for loop because for loops are so much more efficient, right? So, set index value equal to 0. We could just call it I. Set the max index equal to the length of the array. And then while the index is less than the max index of the array, is array at subscript index equal to our target? Great, we found it. Found equals true. And we probably need to keep some value that tells us which it found at. But I'm just going to use this search number right here. This index number is my found. But I could do, another one, found index. I'm going to initialize it to -1, but if we ever find it, I'm going to change it. And we did find it, right? So we found that value. We found that element in the array at this index value, right? So index value is good. Then we add one to index, right? Why? Because if you don't update your loop control variable, you get an infinite loop. Alrighty, now by the time we get here, if found is equal to true, or I could just shorten that to if found. Great, do something. Tell the user we found it. Do something with the data. Oh, come on. At found index. So you could pull that data out and do something with it, right? Print array at that specific place, found index. But if we get to the end and found was equal to false, we never set found index to a good value, right? So we're sunk at that point. So we just have to say, file not found, or value not found, target not found. Now this isn't the most efficient way of doing it. Why do I say that? Because it would search to the end, because there's nothing causing it to break out of the array. So it always starts at element 0. It always goes to max index -1. If your array is 10,000 items long. So we might want to put a while statement in there, or we might want to expand our while, or we might want to put a break in there. I'm pretty sure the book I don't recall the book talking to us about break statements, but I know we have. A break causes us to bail out of the loop, right? So we could just say that. Stop searching at that point. The other way to fix it is to say while index is less than max index and found is equal to false. Keep going while it's not found. That's the more strict textbook way of doing it. So leaving off the break, I'm going to do it like that. We could replace this code in our language with a for loop. Something like this. For index in range starting at 0, going up to max index, or max index? I must have wanted Mexican food today. Yeah, max index, adding 1 each time to it. And then if the array at that index is equal to our target, then we found it. And we found it at that specific index value. And then we're done. It's a little bit shorter than this, right? A little bit. Not much. It doesn't let us break out, so we have to tack on a breakout, and all of a sudden it's hardly any shorter. How many lines code was this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's not shorter. But maybe it's clear. Is that clear? I don't know. It is to me. Maybe not to you. That's the way to do it with a while loop. That's the way to do it with a for loop. So, or you could use a for loop. But this is written in Python, right? It's not written in pseudocode. As a matter of fact, this is written in Python too, except it's supposed to be if, not is, and you have to have colons, right? Okay, so I flipped using pseudocode to Python, so I'm going to go ahead and fix it all, right? What is the command that gives us the length of the array in Python? Have I covered that yet? Yeah, surely I have. So it's len. Thanks. Okay, so that's how you do it. We ought to flowchart that. I bet that it's flowcharted into text. Do you remember that third kind of for loop I showed you, the for each loop? You couldn't use it. For value in array if value is equal to our target. Well, great. We could say found is equal to true, but we have a problem. We don't have an index number. We don't know where we found it. All we know is that we found it. So a for each loop is not good for linear searches or any kind of search. It's great for adding values up or printing them out, stuff like that. Not good for this. Why did I stick the break here and not in this one? Not in this loop? Because I can't think of a way of changing my for loop. I think my syntax is wrong there. I don't need a parentheses there. I slipped into C++ or Java there. But anyways, where was I going? There's no way to bail out early from a for loop unless you use a break, because we can't expand this condition right. But a while loop, you can make your condition as complex as possible. So I guess when I've said there's nothing you can do with a while loop that you can, that you can do with a for loop and vice versa, it's still strictly true, but you do have to rearrange the logic a little bit. So maybe I should have put a break, in here anyway so that the logic would match exactly. If we flowchart it, we're going to flowchart it like this. I'm going to copy and paste all the necessary stuff. I know it's going to... Nah, I'm not going to. We'll probably recreate that in actual Python code in our lab, our coding section of the lecture. So, to search the array for an exact match, you have to have a flag. What is a flag? It's a true-false variable. It's a Boolean variable that indicates whether an event is found, whether an event occurred, right? So I set my flag to false. I'm looking for someone, that's required age. I find you. I set my flag to true. That's just to tell the computer that I did find it, so that we can do something good, right? We could print information about that item or go ahead and check it out if it's a library, or ship it to them. So you set a subscript variable, an index variable, remember those terms are synonymous, to 0 so that you started the first element. You initialize that flag variable to false because you didn't find it. You examine each element in the array. If the value matches, set the flag to true. If the value does not match, increment the subscript and examine the next array element. So this doesn't show using that found at variable that I did to record the index. There are other ways you could write it so that it didn't do that, but I don't even want to bother. When I say I don't even want to bother, I don't want to, keep throwing code on the screen at you. But here, if I give you 5 different versions of it, then they're probably all going to blend together. The human brain likes 3. That's why jokes are always written 3. You have something happen, you have something funny. Something else happen, and the third one's a funny one, right? If you had to go through 7 ones before you got to the funny one, it wouldn't be a very good joke. Anyways, so like you can see that. The size of the array is 6. They allocate something out to the size of the array. This is not Python context syntax. It's not Java, C++. This is some generic pseudocode one. We create a number called sub. We create a string called founded. Bad item count. They're doing something a little bit different. Anyways, get ready. Get ready is enter the item number, right? We had that input statement. And then is our item less than or equal to, I don't really like this flowchart. This is kind of lame. This is kind of lame compared to what we sketched out. I want to draw our own. If your eyes are rolling up looking at something on the screen, you'll learn a lot more when we draw our own. All right, go to our favorite drawing program. Some people with touch screen laptops, they don't like the fact that Lucidchart doesn't support the touch screen or the stylus. You have your Microsoft Surface or whatever. All that great. And so they go and find another one. And that's cool. Log in with Google so I can get on with my school address. And if I pull my code up, I'm not going to do the for loop. Instead, I'm going to do the while loop. Flowcharting with break statements is kind of non-standard. So I'm going to do the version that doesn't have a break statement. Remember a syntax. While the index is less than the max index, and we haven't found it yet. Oh, that's one of the things I needed to talk about. Let me go blip back to our Boolean homework. I initially graded something wrong. Only a few of you have looked at your feedback to see me count it as wrong if you got it right, or to see me count it as right if you got it wrong. Thankfully. But a couple of y'all have read your feedback. I went ahead and updated it. I reposted it. If you saw your grade change, then I apologize for that. The problem is question 46. 46? Where did I come up with that one? There's 25 questions. My brain just had a total seizure. All right, so our Boolean expressions. Wow, that was a long time ago. Halfway semester ago. Why are half of our assignments scheduled just in the last month? Am I putting too much homework on y'all? If you think I'm putting too much homework on y'all, let me know. Send me a text, email saying, I'm really having a hard time keeping up with you. Slow down, dude. I'll take that into account. Alrighty. But on the other hand, most of these are short assignments. So, alright. So here was our homework, if you did it. Hope you did. I haven't checked to see how many people haven't done it. So here it was. We had some values. A is equal to 2, B is equal to 50, C is equal to 100, D is equal to Yoda, E is equal to Vader, F is equal to Falcon. I'm just going to tack this stuff away over here. All right, one thing to note is that Python, being its own weird beast, is a more generous language in some contexts than other languages. And so, you know, our possible answers were true, false, false or invalid. Python will count some things as not being invalid. So if you took the time to type all these expressions into Python rather than figure them out yourself, which is a really bad idea because then you don't understand the logic, then it would give you an answer, even if it was invalid. What is an invalid one? An invalid one is when you're comparing types that are not the same, or at least compatible. So if I did this in the vast majority of languages, if A is equal to, you know, Yoda, or I did if D is equal to B, something like that, right? Python would go ahead and go, I don't mind if you do that. I'm just going to tell you that that's false. Yeah, that's what Python says. They're being generous. Every other language would say that it's invalid. The textbook would say it's invalid. Why? Because this is a number. This is a word. You can't compare them. Even if you did if A is equal to 2 and you thought, well, that's a 2. That's a 2. They're stored completely different in the computer memory. This is a binary 2, you know, just like we were writing all of our zeros and ones and, you know, and add up to 2. This is a string 2, which is stored completely different. It's stored in ASCII or Unicode or whatever. And so that, you know, we could look up the value of a 2 in the ASCII chart. It's sure not going to be the number 2. Just a refresher. Some of these are so hard to see. Google, by the way, in the past year or so, after being sued by Getty, one of the people who sell stock images, so you can't just click on that and have it load up the image. Instead, it goes to the website. But if you want to view the image and you're using Chrome, you can still right-click and do Open Image and Tab, and it'll just pop up the image right on the website. Okay, so anyways, our number 2 in ASCII is equal to the value 50. So if you have the number 200, you know, 2001 typed into your computer, if it's stored as a string, if you looked at the bytes in your memory, you would see 50 and then 48, 48, and then another 49, right? Because those are the ASCII values, 2001, 50, 48, 48, 49. Obviously, that's not equal to the number 2001, right? So if we did in our computer, in our programming language, if 2001 is equal to 2001, Python at least has a good sense to say that's false. Every other language would blow up. It would crash at that point, unless you put some code in there to handle crashes. And you can do that. You can do that in Python. You can do that in pretty much any other language. Whenever a program crashes, it means that the programmers weren't smart enough, or no, not smart enough. They weren't detail-oriented enough to make it handle the crashes. But anyways, that's invalid. Invalid types, right? Because this is a 50, 48, 48, 49 stored in memory. This is just the number 2001, which is, you know, a series of bits that represent the number 2001. I'm not going to figure out what 2001 is in binary, but it's certainly not 50, 48, 48, 49. So you cannot compare strings to integers, which is what some of the questions were asking you to do. So those should have all been invalid. If you type the code into Python and you put false rather than invalid, half my suspicion is going to be that you typed all this stuff into Python to see what it would evaluate as. And so it gave you the wrong answer, that it was not invalid. But that's a quirk of Python. Logic-wise, vast majority of languages, a textbook, it's invalid. All right, so this is not false. It's really invalid, even if Python just told you it was false. There's a difference between the two, right? One causes a crash. One just causes a logic error. All right, and then the other one was the very last question. Where'd he go? All right, way down here. Let's take these both. A lot of people miss 24, so I'm going to go ahead and talk about it. Is that true or false?
True.
It is true. Why? Because you read it like this. If A is equal to A or A is not equal to A. If that was an and there, it would be false because there's no way that something could be equal to itself and not equal to itself, right? We flat out know that this is a true. Textbooks has a term for that I don't remember, for something that is so true that it never becomes false. And this one's never true, right? But we have an or statement. Or just means one or the other has to be true for the result to be true. They can both be true, that's cool, but only one of them has to be true. And in this case, that is true. So the result is true. A lot of people put false there. Not so many in this class as in the other class. The last one is the one that I got wrong. So you can make fun of me. Let's go take a look at it. So some of y'all, I marked it as wrong. I've gone back and corrected it. You either got points back or you got some points subtracted. And like I said, only a few people had read their feedback to actually not, to see me claim that it was right. Okay, is this true or false? Well, a lot of people said false. I said it was false, but it's not. Why is that? Okay, the reason why is because ands and multiplications are kind of equivalent. Ors and additions are kind of equivalent. And when I say kind of equivalent, you remember me drawing those truth tables and showing you why, false or false is equal to false, false or true is equal to true. That's just like addition, right? 0 plus 0 is 0, but 0 plus 1 is 1. So if you treat the zeros as false and the ones as trues, then ors in addition are very similar. I'm not going to draw the truth tables again to kind of prove that to you. Just run with it. And if you're going to do precedence, right, arithmetic, you do the multiplications before the additions. So we mentally break this down, or the computer breaks it down like this. And I'm going to chunk it like that. Either this or this has to be true for the expression to be true. And without scrolling up and proving it, I'm not going to say that that's false.
If you read it first, though, wouldn't the or be able to see?
Either way, that's how it is solved. Does that make sense? You could swap them in order. B is equal to 50, or A is equal to B. Maybe I'm not answering your question. And A not equal to C. If you were going to divvy that up logically, if you were going to kind of chunk it, like I said, turn it into chunks, then you would still do it like this. Just like if you have 1 plus 2 times 3, that's equal to 2 times 3 plus 1. Does that make sense? Hope so. When I ask questions about this in the exam, I'm not going to make it so like it's 10 or 20% of the exam. Obviously, these are hard to think through, right? And on the exam, you might be tempted just to type it into Python. So are you in agreement? Does that make sense? Okay. Because if you were going to chunk this down, if you're going to divvy it up, that, and that. Anyways, this part is true. We could scroll up, see that in fact B is 50. So This half of the equation is true, meaning the whole thing is true because it's an or, not an and. So a lot of people got that wrong, and yeah, it was hard for me to think through as well. Shouldn't have been, but it was. All right. What I wound up doing, and it's what I should have done to begin with, is, I thought, I'm cool. I'm the professor. I'll do all these in my head. And then I got it wrong. So I typed them all into Python to make sure. Okay, so that's the homework. Remember, if you didn't get a great grade on a homework, revise it and resubmit it. And don't just change the truths to falses, right? If you look at it and you're convinced it was true, text a message. Say, hey, 23, you said I was wrong, but I know I'm right. You don't have to be rude about it, but you can if you want to. Hey, dummy. No, I'm kidding. Don't say that. But, and that'll clue me in. Yeah, maybe it was. Or I can explain right on the spot, to you in text or whatever. So don't just flip the truths to the falses. For some of y'all, that would give the incorrect answers because you got the invalids wrong, right? You said it was false if it was actually invalid, just like Python does. Hope that makes sense. Alrighty, we've talked about Boolean stuff. We were itching to draw pictures. Why don't we go back and do that? Like I said, correct it and re-upload it, but think it through. Don't just change the F to a T or an I or whatever. Okay, so we have some code over here that we were playing with. This is our linear search. Create an array, populate it with data. Ask the user for the value to search for, input the target. You know what I'm going to do is I'm going to take all that code and I'm just going to paste it into my flowchart so that I don't have to keep toggling between the two. If y'all screened, you don't set your resolution as low as I do. So you might not have to do this, but it's always nice to have the code just sitting there in the flowchart. So I'm going to do that. I'm going to grab the text over. I'm going to paste it into here. It kind of looks lame if it's tabbed like that. So I'm going to highlight it all. Do the left justify. And there, now I have some code to look at while I'm sketching it. Alrighty. So, start. La-di-da. Create an array. What does that sound like? That's kind of mathy, right? It's going out and it's asking the computer for memory. So I wouldn't put that in a input-output block. The populate with data is input-output, right? Although in our code we just tend to pre-fill the array with numbers. But anyways, okay. Create array. Populate array. Usually you get your data from disk, right? Or you ask a database for data. Or you're building, an array based on how many characters have joined your game, or that kind of thing. So, anyways, the next step, asking for the populating with data, I'm going to consider a data block. I wouldn't count off on your flowchart if you said it was a process as well. If it was this vague, if I didn't tell you how to populate the array. How have we been populating in our code in the past? We just did this, heroes is equal to, Spidey and, Iron Man. Right. That is populating the array, but usually you're not going to declare your stuff like that. You're going to read it from disk or something like that. What if your game suddenly starts supporting other superheroes? You'd like it to just be able to modify your data files. If you can store stuff in data files rather than have to change programs, if you're playing Guitar Hero, you don't want to have to modify the code every time you buy a new song to play on it. Right? That's kind of lame. An even more stupid example, if you have an iPod, you don't want to have to buy a new iPod or download an update every time you put a new song on it. Same idea. If you can put your files in data, if we had a data file that had these names in it, that'd be a better way to populate our array. Okay, so populate the array. If you really hate drawing the flowcharts, I have sympathy. In the real world, I would not draw a flowchart unless I absolutely had to. Just a fact. Maybe you like them. They are very logical. That's the entire point of them. Okay, so we've done this step. Create an array, populate with data. Now ask the user for the value to search for. Now that definitely is input-output, so that definitely goes, you know, input target value. Whatever value we're searching for. We could have called it something different than target. I think the textbook calls it something slightly different. That's not the textbook, even though it's a red icon. Yeah, they call it item. Whatever. That's our target. Now we have some more declarations. Found is equal to false. The found index is equal to -1. Our starting index is 0. Our max index is the length of the array. When they're declarations, declarations are really the only things I don't mind putting all in one process. But if it's math, if it's more complicated than just an equal sign followed by a number, then it really shouldn't go in the same block. So this statement here, max index is equal to the length of the array, I should put in a separate block. But we had 3 declarations. And by the way, I'm holding the shift key down in order to go to the next line. Found is equal to false, or set found is equal to false if we want to speak pseudocode. Found underscore index is equal to -1. That's just to indicate we never found it. You could do away with the found flag and just rely upon found index as your flag. But that's going even further than what the textbook shows, so I didn't want to write it like that. Now our starting index is 0. You know what, maybe I don't know. I am going to put that one in a separate block, but I would not. No, I'm not. I'm not going to even tell you why I'm wrestling with that. Yeah, I will, because it's almost part of the while loop, right? You have to set your index equal to 0 before you go into the while loop. If it's a for loop, though, you know, the for loop creates that variable on the fly and initializes it. All right, we've done all this except create the max index. That is mathy, but it's a calculation. So max underscore index equals length of array. All right, we are all the way through here. We're at our while loop. Just like an if, a while goes in a diamond. You all know I've said it often enough that the book leaves off the word while and they just put the condition. I think it makes it easier to read if we actually use the word while. Either way is correct. While index is less than max underscore index. I'm going to do the simplest version first. No, I'm not. No, I'm not. I'm going to go ahead and put the whole thing in. But then I have to stretch my box out larger. So, yeah, change my mind. I'm going to leave it here. But if you were going to code it and you wanted it to be more efficient, you would go ahead and add the second clause, which was and found equals false, because you'd want to leave it as soon as you found it. Okay, so while it's equal to false, what do? Let's go up and look at our code. We have an if statement. If the item matches. If statements go in what shape? Diamonds. So if the array at that index value, if index at our, if array subscript index is equal to our target, great, we found it. I'm moving my arrows a little bit. Remember, you don't have to take a lot of time to prettify it if it's like on an exam or something. I don't care if the text over, spills out of the shape. As long as I can make sense. Alrighty, if we found it, if the element at that index is equal to a target, then we're going to set our found variable equal to true. That's math. Goes in a process block. Assignments is what it strictly is. So found is equal to true. And then we have a second one, which is where we found it at. So our found index is going to be equal to the index that we spotted it at. Found underscore index is equal to index, because that's the place we found it at. All right, this is an if. So this doesn't loop back to the if. You only loop back if it's a while. They just have to rejoin each other. So I'm going to draw a line down here and end it in a little circle. Be nice if you took the letter out. I don't care. And then this one hooks back up with it as well. I'm going to back out for a minute. So we have some setups, and then we start into the meat of the program, which is our while loop. Now I'm going to zoom back in so that you can read the text. By the way, if you hold the Alt key down while you resize it, while you're dragging it, it behaves a little bit better. Here's how it behaves if you don't hold the Alt key down, right? The arrows start getting messed up. If you do hold the Alt key down while you resize it, see, it makes it a little bit better. Keeps it centered. All right. So whether we found it or not, we have to increase our index number so that we can keep searching it. So that's math. Increment index. Add 1 to index. Index equals index plus 1. Index plus plus. Index plus equals 1, right? That's the syntax we've been using. In pseudocode, we said increment, something like that. And then we have to loop back to the while. The textbook always shows looping and going back to the top, but I don't want to draw a line that goes here, here, and then back to the top, so I'm going to draw the line so it goes there. Now we just have one last little bit of stuff to do, right? That's our structure right now. We have a column of code. We tabbed over when we hit while. We tabbed over when we hit if. We end tab there. We end tab there. Now we're done with all that stuff. What's left? We're going to check to see if we actually found it. So down here at the bottom, it'd also be okay if you drew the no from the other side. We're going to do another if. If found is equal to true, or just if found, that's the same way as writing if found is equal to true. Then we're going to print, we're going to do something with it, whatever our something is. I'm just going to put it in a process block. Do something with array subscript found underscore index at the position we found it at. And why do we take the time to both code it and draw it? Just to burn it into your brain. You know, some people are purely visual, right? Some people, you know, are symbolic thinkers, you know. Just like some people are more artistic and some people are better writers, you know. People say left brain or right brain, and that's kind of true, but not totally. Alrighty, but if we didn't find it on the no side, we would have to give them some kind of error message, tell the user, you know. I'm just going to print an error message. Print or output, whatever. I've been making it look like Python, so I may as well use the word print. Target not found. What do we do at that point? Maybe we ask them if they want to keep searching, right? If Amazon just quit after you search for an item and it didn't find it, that'd be kind of lame. And this is an if, so again, they have to hook back up together. They need to rejoin. Where's my little circle icon? I couldn't find it, so I'm changing it. I dropped it, and now if you right-click on something, you can always do change shape. You don't have to delete it and redraw it. And I've passed a page border, and I don't care. If I was going to print it out, I would worry that this dotted line was cutting through my shapes. All right, and now we're done. We either found it or we didn't. Fine. If this is a module, we'd put a return there, right? We might return the index at which it was found. We might have passed in the array to begin with, rather than populate it right on the spot. Alright, and as always, I try to condense the stuff so that I can get more of it on the screen, and of course I fail, so I'm only showing a little bit of it for y'all. But if I zoom out, that's my structure. This is the last part we did with our while loop and our if loop. Now I'm going to zoom back in a little bit. I'd like for you to always put your name and stuff on it, so I'm going to drag a block over so I can just put my name on it. Jeff Thompson, CIT, you know, 1113. Chapter 6, linear search. Hope that makes sense. This is an expression of the logic of our code, our pseudocode that we did. All right, anybody need me to scroll up and down, show a specific part?
Please.
Pardon me?
Yes, sir. There you go.
And I can always print it out if you need the printout. No shame in that.
Appreciate it.
Can I get a print?
Absolutely. Okay, so what do we do when we're done with our flowchart? We save or save as. I'm just going to call mine linear search. And then we did that under file, of course. And then we do file download as. I like PDFs. If you were going to open it in Microsoft Word, in Microsoft Office's flowchart program, you download it as a VDX. That's what they call their own flowcharting program. And then they just save it somewhere good, like your fundamentals directory. Then I'm going to open it and print it. All right, for the benefit of those watching at home, I'm going to do a slow scroll from beginning to end. All right. If we were going to modularize it, which I'm not going to, that'd just be extra work at this point. I would modularize it at this point. I would start my module with the declarations, and then I would make it return the index. So from here down to here would be the returning of the index, the found index. And remember what we set found index equal to? We set it equal to -1. So after we called our module, if the index was equal to -1, then you know you didn't find it. That's a way to do it without using a flag. All right. We are about conceptually done with this chapter, even though it looks like we're only partway through it. But that's because we are awesome. Parallel arrays, I've mentioned already. See what I mean? We've already covered this. Parallel arrays are when you have 2 arrays, or 3 arrays, or 4 arrays of the same length, where the data is hooked up thematically by their index value. And that's the way a spreadsheet works. So you're making a birthday party for kids. You know, you have a first name column, you have a last name column, you have their favorite dessert, and their favorite color. So you can give them food on blue plates versus orange or something, and heaven forbid they say their favorite color is chartreuse or something. Okay, so, you know, something like that. And I'm going to add one more column just for the index value because they don't hook up right with these numbers, because we would want to start counting as 0. So I need to insert a column. This is going to be the index. And yeah, in Excel, you can go to a lot of effort to make things pretty. So anyways, this is the index to all the other arrays. 0, 1, 2, 3, 4, 5. And so Brad is coming to the party. Brad Pitt. Selma Hayek is coming to the party. I may be misspelling these names. Apologize for that. And very quickly, I'm going to run out of names. Leonard Nimoy. Mark Hamill. We've got a lot of science fiction people coming here. And I know I've misspelled that as well. Whatever. That's enough. I'm going to delete the last 2. Then we have their favorite foods. Brad Pitt, for some reason, likes rice. Selma likes ice cream. Leonard likes cake. Mark Hamill likes pizza. Favorite colors. Brad likes red. Selma likes blue. Leonard is very strange and says that he likes beige. And Mark likes white. There we go. So these are parallel arrays. We would allocate arrays of length 4. We would read this data in from, you know, ask the user for input, read it from a disk, something like that. And then when we wanted to find out what this kid wanted, we would use index value 2 for each one of these arrays. Yeah. We would print out first name index 2 plus last name index 2 on the invitation. On our shopping list, we would print out food index 2, and we'd buy him beige index 2 napkins, whatever. Excuse my slight perfectionism. I really think Hayek is spelled with an E. What? No, forget it. I don't know. Anybody know? How do you spell Hayek? You think it's correct? Okay. So that's our example of a parallel array. There are 4 parallel arrays. If we were going to declare that in Python, it would look like this. We're running close on time, but I don't mind us doing this in Python. I don't think it'll be too much typing. So go ahead and load up idle. Name, date, parallel arrays, birthday party. And we're just going to populate our array, not by asking the user for this stuff, but we're just going to hard code it like we have in our other arrays. I'm going to shrink this stuff down so that I can type, right? Okay, so f name for first name is equal to, or f names, you know, because we have more than one of them, is equal to Brad, and then we have Selma, and then we have Leonard, and then we have Mark. Then last names, L names. L names is equal to the names that were on our list. Pitt, Hayek,
So Y-E-K.
Nimoy, pardon me. Oh, it's Y-E-K?
Yes, sir.
Okay, thank you. Nimoy and Hamill. I probably got that one wrong too. Alrighty, and then their favorite foods. I may skip the last part of the array, the colors, just to save time, but you understand it. Rice, ice cream, cake, pizza. Then we would write a loop to print that stuff out. For loops are easier to write than while loops. While loops are more classic. I guess I'm going to do a while loop. So, I is equal to 0, our index counter. While I is less than the length of, since the arrays are all parallel, they all have the same length, so I can just pick one. While I less than len parentheses f names. Or we could create a variable for that, right? We could call it max length or whatever, max index. Alrighty, now we're going to print their stuff, right? F names, subscript I, comma, L name, subscript I, comma, foods, subscript I. It's not going to be nicely formatted or anything, but it'll work. And then, since it's a while loop, we have to update our loop control variable. I plus equals 1, or I equals I plus 1. Whenever I type I plus equals, people start putting spaces in them. No space between the plus and equal. Alright, and then we're done. I think I'll just print a done message at the bottom. Even better is to put an input statement, right? Press enter to finish, that kind of thing. That way, if you double click on it from the user interface, you know, from Windows, you download it and run it, you at least get to see what it does before it closes the window. Alright, I'm going to save it. April 19. I'll bring the code back in just a second, sorry. But I better run it. Alright, there we go. Brad Pitt likes his rice, Selma likes her ice cream, Leonard likes his cake, Mark likes his pizza. That's the idea behind parallel arrays. And we covered it once, but it's important enough that I wanted to cover it again. What is another way of handling this? Another way of handling this is to create some kind of structure that holds all three pieces of data, and then just have an array of those structures. Not that we've covered that concept. All right, I'm going to stop the recording, make the Dropbox, walk around,